Alright, for the rest of chapter 12 we're going to be dealing with a topic in mathematics called polynomials. And so 12.4 is kind of an introduction to that topic. Give you a brief definition. This first video really is going to be full of definitions, so you can start to understand the language of polynomials. Okay, so we'll start with a quick definition. A polynomial is a term or a sum of terms where all variables have whole number exponents. Now this definition is slightly different from the one in the book. I'm going to try to give you a little bit more detail here. And so the variables all have to have whole number exponents. That means we don't have any negative exponents in polynomials, which I'm sure you'll all be relieved about. So all the exponents are either 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and so on. Okay, those are whole numbers, starting at 0 and going on indefinitely, increasing by 1. So those are our powers. And then the idea of a term and a sum of terms. You guys know what a term is. It's just a term is something that's being added or subtracted. Okay. So some examples, lots of examples of polynomials. Maybe I'll change color here. Lots of examples. Things like 5x plus 2. That is an example of a polynomial. It may not look like it at first, but x does have a power on it. It has a power of 1, right? This is 5x to the 1. And this 2 also kind of has a x on it. You don't see it here, but it's 2 times x to the 0. Remember, 0 powers are really 1, right? 2 times 1. So this thing does have the form of a polynomial. The terms in question, the terms are 5x and 2, right? So here actually it's a sum of terms, the sum of two terms. Another example may be 3x squared minus 8x plus 7. Right? Again, we have a sum of terms. There's 3 terms. The terms are 3x squared, negative 8x, and 7. And each of the powers are whole numbers, a 2, a 1, a 0. Okay. All right, now I'm going to add another definition into the mix here. We're going to talk about lots of different things here. Some of these you may have already seen, some of the definitions you may have already seen. First thing is the degree of a term. The degree of a term is the power on the variable in that term. Okay, so the degree of a term is the power on the variable in that term. Now there's a couple details to straighten out. Excuse me, to straighten out here. One detail is that in some cases you may have more than one variable on a term, like 3xy. We're not actually going to see that in this class, so I'm not going to worry too much about those, but if you did have something like that, then you actually have to add the powers together. The other thing to consider is that, what was the other thing I was going to say? The degree of a term, power on the variable in that term. Oh, is that a constant will have a degree of 0. Okay, because there's kind of an x to the 0 hiding out here. So, for example, for 5x plus 2, the degrees are going to be 1 and 0 for the corresponding terms. For 3x squared minus 8x plus 7, the degrees are going to be 2 1 and 0 respectively. Okay, so it's always the power on the variable. That's the degree. Now, polynomials are actually categorized by their degree, and so we actually have a degree for the whole polynomial. The degree of a polynomial is the largest of the degrees of the terms. Okay, the largest one. So for that first example, 5x plus 2 has degree 1. It's the largest of the two, right? The terms had 1 and 0 respectively, and so the polynomial itself would have degree 1. It's the power of the largest one. 3x squared minus 8x plus 7 has degree 2, because 2 is the largest power. It's the largest degree of the terms. Okay. So individual degrees have their own, or I'm sorry, individual terms have their own degree. It's the power on the variable, and each polynomial has its own degree, and that's the largest of the degrees of the terms. Okay, now each term has a couple different parts to it. The first thing is you have the number and the variable. Okay, so each term has numbers and or variables. You may have one or the other. You don't have to have both. The numbers are called coefficients. Okay, so in the example of 5x plus 2, the coefficients, let me write this out, 5x plus 2, I'll abbreviate coefficients there. The coefficient would be 5. Now, some textbooks are going to include the constant as a coefficient. I don't know. Here. I don't know that this book even really addresses it. Yeah, I'm not seeing where this book even addresses that issue. So I'm going to go ahead and include it, even though a lot of people would say that may not be necessary there. Also, in the example 3x squared minus 8x plus 7, the first term has a coefficient of 3, second term coefficient negative 8, and I would include a negative if there is one, and then the third term has a coefficient 7. All right. Also, the coefficient of the term with largest degree is called the leading coefficient. So that'd be the 5 and the 3 in these two cases. So the leading coefficient is from the term with largest degree. Okay, so in the two cases above, the 5 and the 3 are the leading coefficients. Okay. All right, a couple more definitions here before we move on. Need a new sheet of paper. The next one would be the leading term. All right, the leading term in a polynomial is the term with highest degree. Okay, the term with highest degree. So for 5x plus 2, the leading term is just the 5x. For 3x squared minus 8x plus 7, the leading term is just the 3x squared. It has the highest degree. Okay. Okay. Just a couple more definitions. One of them is called the constants. Constants are terms without a variable Okay, so in the case of 5x plus 2, the constant would be the 2. And in the case of 3x squared minus 8x plus 7, the constant would be the 7. Okay, constants are the terms without a variable. Or you could think of it as, or the variable to the 0 power. Okay, so kind of mentioned that earlier. All right, and then finally, we're going to look at 3 specific types of polynomials. One is called a monomial. A monomial has only one term. Has only one term. A binomial has only 2 terms. And finally, a trinomial has only 3 terms. Okay. After that, we don't have any special names. There's no special name for a polynomial with 4 terms or more. All right, that should get us through all of our definitions. Should be able to see all the details there of how these things interact. The next video, we're going to talk about working with polynomials, finding values when you plug numbers in.